All right. Good morning, everyone. Thanks again for joining us. My name is Sarah Husky with 3C Ren. I have started recording this course, which will be posted on our on-demand page. Today, we have Ken Levinson with us to talk about all-electric decarbonized passive house apartment buildings. But before we get going, I just have a couple slides to run through. Great. So we just ask that everyone make sure that they're on mute throughout the course. If you'd like to ask a question, please raise your hand and we'll be sure to call on you to unmute yourself. But we also encourage you to participate and ask questions through the chat. We'll be monitoring the chat as well. So a few words about who we are. We are the Tri-County Regional Energy Network, also known as 3C Ren. We're a collaborative partnership between the counties of San Luis Obispo, Santa Barbara, and Ventura, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which are collected through the public goods charge found on our utility bills. And the benefit of being ratepayer funded is that there's no cost to those we serve, and we are able to return these dollars back to our local economy, which have historically missed out on some of these funds. And next slide. One of our programs is our Energy Code Connect, which serves building professionals by offering Title 24, Part 6, and Part 11 support. Within our Energy Code Connect program, we have our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for both residential and non-residential projects. And next slide. As another program we have is our Building Performance Training Program, which serves building professionals by offering technical and soft skill trainings related to building science principles and high performance buildings. This multifamily passive house course is brought to you through this program. The next one we have is our Home Energy Savings Program, which incentivizes contractors and helps residents save money to make their homes healthier with energy efficient upgrades through incentives and rebates. And I'll just note too as well, we don't have our updated slide deck yet, but we are launching 3 new programs, which are on our website. We are launching a commercial energy savings program, which incentivizes contractors and to put in energy efficient equipment into small and medium-sized businesses. And then we also have our Ag Technical Assistance Program, which does utility bill audits for indoor growers. And then we have our Energy Assurance Services Program, which makes community buildings resilient during emergencies so that they can stay open and keep the lights on. So just highlighting those are 3 new programs that we're launching. And if you're interested, you can go to our website and check those out. But with that, I'll pass things over to Ken.
Great. Thank you, Sarah. It's great to be here. Great to talk about multifamily passive house, zero emissions multifamily passive house. My name is Ken Levinson, as Sarah mentioned. Great to be with you. I'm the executive director of the Passive House Network. Just a couple of quick words. We're a nationally focused 501c3 non-for-profit. We do have a number of regional chapters, including Passive House California, and very excited to be active across the state of California. We're really focused on training, peer-to-peer knowledge sharing, connecting people to resources to build capacity to deliver passive house buildings. One of the great parts of the passive house community is that folks really are quite open and sharing in the knowledge and the experiences that they've had. And I think it's really, folks are pretty mission driven in the community and want to see everybody truly succeed. And so if you have questions, I'm certainly going to try to help you out today. But going forward, feel free to reach out, and others in the community. If you see something you like, see something you have a question about, reach out. We work with certifiers from around the world, building certifiers, as well as the International Passive House Association. it's really a global community, and we love to take advantage of that. So I won't go into the depths of all of this. I will say a couple of words about myself. Just that by background, I am an architect by training in background. I practiced for a couple of decades. I did some early passive house projects and really was compelled by the methodology and what we were able to accomplish, and kind of got into then the education and advocacy part of it. Um, Around different associations. I also want to note before we get started, I want to give special recognition to a dear but lost friend and colleague, Monty Paulson, and his estate for some of the content of this, and the fact that Monty and I were working on this multifamily project for the last year and a half, and he very sadly passed away, died unexpectedly this summer. And so he'll be greatly missed. I want to make sure I just give him a shout out. He's greatly missed. So the agenda today, we're going to cover a lot, and I kind of apologize in advance. It should be very engaging and interesting, but we're gonna hit the context, kind of larger picture, basics of passive house. I am assuming a certain level of knowledge of passive house, and it could be quite rudimentary, but some idea. If you do have some basic questions, feel free to throw them out, and I'll try to make sure we address them and bring everybody along. We're going to be talking about the milestones of doing a passive house, um, the efficient multifamily design, key aspects of that, and then different characteristics of successful multifamily passive house buildings: ventilation, exterior shading, glazing, walls, thermal bridges, the heating, cooling, hot water systems, electrification, of course. And electrification is going to come through all of this, as is the approach of zero emissions, and then getting to certification. So in a way, this course is very much going to be dealing with delivering a zero emissions building, but is also about just delivering a high quality passive house multifamily. So it's ambitious, and I hope you'll come along for the whole ride here over the next just shy of 2 hours. So the context of zero emissions, and really a more common term, zero net energy, in a way that's related to it. We're going to the context here. I have to look at the right screen. Um, Zero emissions buildings and zero net energy. So we have, of course, Title 24 in California, and really moving towards this goal of zero net energy, which is great. And we want to just clue in on this, that as defined by CPUC, energy efficient building, where on a source energy basis, the actual annual consumed energy is less than or equal to the on-site renewable generated energy. So we're producing as much as we're consuming over the course of a year. Is one of the long-standing goals, and is quite common. The Department of Energy recently, earlier this year, came out with a zero emissions definition, which is very slightly, and it's interesting, three main characteristics. It must be energy efficient, and it must not have any on-site emissions from energy use, and it must only be powered from renewables. So there's not necessarily totaling of production and consumption, and it's not making you hit specific numbers, but pushing you towards energy efficiency, pushing you towards electrification, and towards renewables. So these two work together, I think, and kind of form the umbrella of what we're trying to achieve with these buildings. Where passive house comes in interestingly, and this is a whole other class really on electrification to dive into, but just at a high level, where traditionally on the left, we have uh, um, the source energy kind of calculation of um, of the energy and energy losses in production of the energy, the transmission, and then the final use. Um, and this is based on essentially a fossil fuel based production of energy. Passive House is shifting. You can still calculate it that way, but what they're really looking to do is say, you know what? We're moving to electrification. We are moving to a 100% renewable grid. Um, and what's going to matter the most is not so much the source energy, because it's going to be renewable energy and the amount, but the simultaneity of our use of energy with the production of energy, if that makes sense. And this is, so what Passive House is looking to do is to make the building align and be as friendly to an all renewable, all electric power supply grid. Uh, there's a lot underneath that, of course, and we'll come back to it in the electrification section, as well as some other stops along the way. The fundamental problem that we have is that in um, a net zero building can be exemplary in terms of matching up to the grid, but it doesn't necessarily need to be. And oftentimes we have a very high demand over the winter heating seasons, um, with very low renewable production capacity. So there's this big gap um, between the supply and the demand. And then we have overproduction in the summer where the demand is lower typically and the supply is greater. And so we have this mismatch, and Passive House kind of helps tune the building. So we're really crushing that heating load, um, and it's not going away entirely, but the gap is much more modest, as well as matching up the electric production to the demand in the summertime. Um, and so what we're trying to avoid is storage losses. And if I could go back one slide. So on this slide, you have short-term storage losses, um, you know, day to day, week to week. And then you have seasonal storage losses. And the seasonal storage losses are much more inefficient, or much greater. And so we're trying to minimize those to the greatest extent possible. And in a place like California, uh, it's still, there's a lot we can do, and a lot that we can do to move the needle and relieve the pressure on the grid. And so we see in several climate zones here, the total reduction of being significant. Obviously, the harder the climate, the more savings potential that there is, but significant across the board and meaningful. So we are looking to electrify. Passive House does not demand electrification. It's a sort of another conversation, but it certainly incentivizes it and moves the conversation into an all electric, all renewable context. The other thing we want to note in terms of the context as we go in is that Passive House, looking at efficiency, looking at zero emissions and um, electrification, is, well, it's really known and focused on efficiency. The efficiency is underlying what we value most, right? Things like healthy people in indoor healthy environments, that they're resilient, that it's cost effective, that we have safety, sustainable, uh, and so forth. And so I like to say, and as an architect, when I was doing the projects early on, early Passive House projects, uh, I would speak to the client about what they cared about, not necessarily what Passive House agenda was. And many of the clients, what they really cared about was the health of their children. They cared about acoustic comfort. They cared about resilience. And that's what we addressed. And Passive House was able to do that. And with multifamily, we're able to do that at scale. One thing we want to note as we dive into delivering a passive house multifamily is that construction's complicated. There's a lot of moving parts. There's a lot of things for the builders to be concerned about, for the whole team, the engineers, architects, the owners. It's easy to get lost. And one thing that we really want to do is have as clear a path and supported path to keep you focused on the passive house objectives and to get you through to the other side. Perhaps parallel to that is just to note that passive house does not need to stand alone. Passive house is a very narrow focus of objectives in some ways, and people may have other things that they want to bring to it, especially in multifamily. And so there's a range, and you can mix and match different certifications as you wish, what the objectives are. Just, I think, 2 slides maybe on the, or 3 maybe on the fundamentals of passive house, at least how I like to think about it. Again, going to the fundamentals, and you'll hear that again and again in a few other aspects as we go through this presentation. That Passive House uniquely masters the elements of high performance building in a really simple and elegant way. And Wolfgang Feist, who's the founder of the Passive House Institute, kind of has this wonderful quote here on the left. I was working as a physicist. I read that the construction industry had experimented with adding insulation to new buildings and that energy consumption had failed to reduce. This offended me. It was counter to the basic laws of physics. I knew that they must be doing something wrong, so I made it my mission to find out what and to establish what was needed to do it right. So here we have, insulation is a basic ingredient of high performance building, and the builders did not know how to use it to actually get a better result. I like to think of it as similar to cooking and what it means to understand how to make a great meal. And this wonderful book by Simon Nosrat, Salt, Fat, Acid, Heat. There are 4 basic components of, what drives great cooking. And if you can master those 4 components, you can make a great meal out of all sorts of foods and combinations. And so really, it's about narrowing the focus to get a wider impact. Another way to think about it is, so the criteria for buildings, which is what's driving the passive house metrics and the goals on the project, are built on this idea of hygiene, human hygiene, hygienic conditions, human comfort, and energy efficiency. And we may expand that a little bit, saying health, comfort, efficient. Also, durability is a key aspect, and that we're doing it affordably. And Passive House is able to do this by calculating in a highly predictive way outcomes in the design of the building in an integrated way using the Passive House planning package, the PHPP energy model. And what it allows you to do is to take what people often feel as being contradictory objectives, like energy efficiency and comfort. I remember I was little, but I remember Jimmy Carter, telling us to turn down the thermostats and put on a sweater. It was not, energy efficiency was not about comfort, it was about discomfort and how much you suffered in a way. Passive House, through its methodology, aligns efficiency and comfort and health. So the more energy efficient it is, the more comfortable and healthy it is, and vice versa. You get a virtuous cycle. And that's a little bit of the conceptual magic of it. There are 5 basic principles. I won't go into these in depth at all. Climate-specific insulation levels, typically normal, above what code is, but in multifamily, not necessarily the case. If depending on the size and orientation and optimization. Thermal bridge-free connections. It means that that insulation is as to the greatest possible uninterrupted. Think of it as a thermos. We do not want pieces of construction, structure, window frames, things that are thermally poor, uh, interrupting the quality of the overall thermal enclosure. We want to have it be thermal bridge free. We want it to be airtight. We want control of the air. We don't want drafts. We don't want to allow the wildfire smoke, the pollution outside in. We want to be able to maintain a clean environment. High performance passive house windows and doors, they're extensions of the enclosure, the insulation, and the air tightness. They give us some passive heat gains, but we also want to protect against um, overheating, and shading. Solar protection is key, and we'll be talking about that. You can use it for natural ventilation. You can, if the day's weather is appropriate, you can open the windows and let the breeze blow through. But oftentimes, either because of pollution, because of the weather, uh, it's not appropriate to open the windows to have fresh air. And so we're supplying sort of guarantee of hygienic ventilation, where we're constantly supplying fresh air, constantly exhausting the stale air, and using a passive heat exchanger to recover that heat and not waste it. So it's very energy efficient while we're maintaining very high indoor air quality. Again, the energy model is driving the predictable performance. The logic, as I like to break it down, is that as we see, and as Feist saw with the builders in Germany with the insulation, that the building industry in many ways is disconnected from the design and construction decisions and how they affect the actual ultimate performance of the building. And the passive house is a really compelling way to connect the dots and make those connections really obvious and make everybody aware of them. And so in doing that, it's empowering us as architects, engineers, owners, developers, builders to deliver the performance that we're looking to get. One last note on kind of the context is affordability. You know, these are high quality buildings. They are going to, especially in the first projects, they're often going to cost a little bit more, but they should not cost a lot more. If they're costing a lot more, something has gone off the rails. Some different resources on the costing. And I should note, I can provide all the links. I actually have a PDF copy of this presentation that I can share at the end, and you can have all the links to everything. This diagram on the left is it's of multifamily buildings in Pennsylvania over a number of years, and the conventional dots, the black dots are conventionally built buildings, and the blue dots are passive house buildings. And so we have down here at $100 a square foot, up heading towards $400 a square foot. And what we see, the takeaway is that there's no direct relationship between passive house and cost. Some cost more, some cost less. There are lots of things that drive cost in a project, and we can manage that. And there's a lot more experience now. We have a great publication called Safe at Home. I encourage everybody to download it and take a look. A report that we did on cost barrier and passive house and what we're seeing in the market. And another great resource from Vancouver. So with all of that, I hope the table's kind of set for taking a deeper dive into multifamily. And we're going to start perhaps a little abstract still, but talking about the schedule, the milestones, the basic objectives in getting there. And then we're going to kind of pile in all the ingredients of what needs to happen. So, you know, and I guess we could say not just survive, but thrive. You could think about that existentially as terms of life, but you could also think about it as just getting through the project. As we note here at the beginning, constructing and planning, construction, certifying the team's first multifamily passive house can feel like a hero's journey. Many have felt like abandoning it along the way. There is, you know, great comfort to be taken in. The more times you do it, the better it is. And we'll be talking about that using repetition, learning, and hopefully with this is really an attempt to jumpstart folks to learn from others, and be able to have a good time of it. Like I said, the project stands an excellent chance of having little to no construction cost premium, with some basic things, the charrette to kick off, construction kickoff, um, at the beginning of that phase. We'll come back to all of this a few times. The building certifier is retained early, that you're really sticking to that passive house pathway and the milestones that need to be achieved along the way. And that you consider all the items that you're about to get, uh, as we're about to cover here. I'd like to say, before we go into the steps forward, there is a bit of a mind shift in thinking about it in the context of the passive house. And I think you could pick it up on some of the earlier slides, that we're designing with energy now. In a way, kind of like we always have with gravity. We don't question the fact that we have to design buildings according to gravitational laws and goals. Um, Energy has been new because we could basically do whatever we wanted and get away with it. But now we're really needing to optimize. And so the PHPP is that design tool to design with energy. And the PHPP has to be integrated every step of the way. And you'll see that come up again and again. It's the PHPP that's going to optimize the design. It's what you're going to check against to certify. Um, you know, I like to say, embrace the PHPP. The PHPP is your friend. It's a little over, it's a little daunting perhaps at first, but so important. And then the drivers of the energy flow are, essentially the enclosure first. A lot of folks call passive house fabric first. And that's those first four principles that we just talked about, from the insulation through the windows. Um, and then principle 5, the ventilation system. And then the internal gains are really, they're always important, but in multifamily, they're super important. And it's these three aspects of the building design that's really where we're going to get our energy optimization and the performance out of the building. Notice I'm not talked about the heating cooling system with that, but that we'll be covering that. So this is a lot. And again, I look forward to sharing. I apologize a little bit. I look forward to sharing the PDF. Feel free to go back through, flip through it, take your time. And I could follow up with questions in the future as well. I want to hit, these are some common stops along the way, pre-design schematic all the way through to occupancy. We're going to talk about these a little bit more in depth here, but I'm going to just want to call out a few things. The idea of experience is good. Experience is one of the key drivers of affordability and really having that optimization done. But obviously, everybody needs their first project. It's super important that everybody who's on the team is interested in doing it and wants to be doing it, or can be convinced to want to be doing it. The interest needs to be there. It's easy to make something painful like this if you're not on the team, so to speak. If you don't have experience, you need to hire experience, consulting, coaching, whatever it may be. Uh, and then as you're moving through with these highlights here, we're doing a model, the energy model. We're doing the first integrated design charrette. and we're including buffers. And as we move through and develop from schematic design to design development, we're bringing in more detail sooner than later. We're updating the model. Uh, and one of the key things we'll come back to is between construction documents and bidding, you want to have a letter from the certifier saying your multifamily building as designed, if executed as designed, is certifiable. You do not want to be bidding a project out to contractors that's not certifiable. Um, if you can do CM job through, that's even better. But get that assurance before you head into bidding, or at least at minimum into construction. Some jurisdictions now where they have incentives are requiring this assurance letter before issuing the permit, the building permit, so that everybody is much more comfortable with the fact that they're on the right track. As you're also going into construction, make a verification plan. The city of Vancouver requires that a verification plan is in place before they issue a building permit, which I just think is a great idea. There are lots of ways to approach verification, but the most important thing is to um, have everybody at the table and processing it and be on board in terms of what needs to happen. And that includes the building certifier signing off on that verification plan. Pre-construction, the training of the construction crew, mock-ups, multifamily, where you're dealing with lots of repetitive items, mock-ups of the windows, make sure everything, the QA/QC is set in terms of the process. Um, Construction administration really comes down to the verification and going through. We have another class on verification as well, which is quite interesting, going through how to kind of set yourself up for success and in some detail going through all the different aspects. Things that are kind of irreducible for passive house, which we'll come back to, the ventilation commissioning is absolutely critical and can be a real pinch point and a painful point in multifamily, delivering a multifamily passive house. You need to be like really laser focused on the ventilation system, as well as the final blower door test, and getting that building to be able in a position where you can pass that test. And if you do, chances are you won't just pass it, but you can blow it out of the water. We can go really tight with a multifamily building, which is great. You're going to end up with an as-built energy model of that PHPP, like the drawings, the specifications, the whole package. That's what's going to be certified, that as-built energy model. It's not based on monitoring after the fact. It's based on what's built there on the site. And so as you're heading into occupancy, there may be a temporary C of O or a certificate of occupancy, depending on how the jurisdictions are working. You may get a letter from the certifier to make that happen, or you may just uh, get the final certification. We'll dive into that in a little bit more detail as we go forward. So I don't want to totally rehash this, but going through the different aspects here, I guess the big thing about multifamily and these bigger projects is to really have a concise and clear owner's project requirements written out in advance. Um, Ideally, the passive house consultants and the architect, the engineer, everybody involved has done a passive house multifamily building before, but we're still on day one here. We're scratching the surface of the industry. Um, Again, you want somebody with experience. You want to be able to reach out and tap into the knowledge base that's out there. But the more experience that you're bringing to bear in a multifamily, it's going to serve the project well. Um, the design charrette, we just want to re-emphasize, I think folks have become familiar with it through LEAD and other programs that will require it. And it's critical with Passive House in that there are many assumptions that are going in right off the bat into the energy model and as you're developing it. And you want to have a conversation about those things. And key items like the ventilation strategy, like the wall assembly strategy. Um, if the charrette is comprehensive, the team will feel relieved as they depart. Is that it? Because it is the basic ingredients again. It's not UFOs landing from Mars. Um, the big thing that happens, and we'll see this across, and you'll see how it plays out, is that we're really front loading as much as possible critical decisions. Like things have to process and things happen, but really to keep things moving forward. And this was where experience does help to identify those things where you need to really address them. Like as you're moving from conceptual schematic design development through, that you're making those bigger decisions that have far-reaching effects earlier. And in some ways, going into the details. So form factor, talk about circulation, ventilation, shading. Um, One quick note on the wall assemblies, which we'll come back to, is that they don't need to be exotic. They can be, and I think we'll be pleasantly surprised here, that the wall assemblies can be very close to your standard construction. They're just little tweaks. Again, knowing what to tweak to get the performance out of them. And really using and building with the assemblies and the strategies that contractors know um, and can do affordably. It's important to work with those. Don't we don't need to have them figure out how to build again a mission to Mars. Um, in design development, the big thing again, sliding things forward is like how do we get the information as we're locking down in the energy model. We want to get critical details. We want to identify where those thermal bridges might be. The thermal bridges are happening at the, you know, at the floor wall connections, um, at different structural penetrations, at window installs. Um, and you want to, especially when it's your first multifamily project or first of a type, um, identify those details and start drawing them as early as possible, way before CDs. Go back and forth with the certifier, with the consultant, make sure that the details are actually giving you the performance. Again, it's not necessarily that difficult. It's just more about intention. And if you have a bad detail unintentionally, it can really undermine everything else that you're doing. So we want to have the PHPP in design development um, based on actual details and components, not on assumptions. So we're moving from assumptions to more specifications. As we're documenting all of those decisions in construction documents, again, this goes to the design stage assurance review. You want this before. And we still hopefully have a buffer left. So many teams are designing right from day one up to the energy limits, Passive House. And so everything that you do to the project subsequently, you've got to do something else because it's adding or subtracting or what, you're dancing right on the head of a pin. It's much better like a construction contingency for costs, you have a bigger construction cost contingency early in the project. And as you get later, that contingency is reduced. Similarly with the energy budget, just treat it like another budget. And in multifamily, super, super important. Bid, lockdown, QA/QC, the verification, leave it there for the moment. Another key aspect, especially as with the multifamily, but all buildings, is empowering the team and construction administration through the kickoff, doing a workshop, making sure there's adequate planning. There's a lot there to make it work, but perhaps for another day in terms of diving into more detail. Um, the one thing I would say on occupancy and the certification at the end is this idea of tuning the building. You're going to move in to the to the building. It's a big building. There's lots of units, occupants, different systems. It's not uncommon for the mechanical systems to take some time to iron itself out in terms of the actual operation. The software may not be working. Somebody turned a dial the wrong way. Somebody turned something off. The managers aren't as familiar with the building yet. Um, and what we've seen is that it may take a couple of seasons, but once they've allowed for proper commissioning, that the building will function as predicted and will provide the results that are intended. But we don't want to just think that we flip the switch and we walk away. All right, so that's kind of like just setting the context of moving through it. Here we get into some specifics about efficient design and multifamily. Um, we want to lay out the mechanical distribution space needs early. We want to plan shading before glazing. That sounds weird. We'll talk about that a bit. Minimize the surface area, calculate the form factor, minimize the circulation area. So this is in the purest sense, we're just talking about optimization, right? Make it as easy as possible to hit the numbers. You can make it harder to do, but we want to start from a point of making it as easy as possible to achieve. We want to minimize the circulation, kill bad balconies, articulate the skin, not the thermal enclosure, have clear control over what's inside versus outside of the passive house occupancy, slightly higher ceilings, and repeat what works. So these 10 things are really key aspects, in particular, of multifamily buildings and what we've seen work. So let's go through each of these in a little bit of detail. Um, Layout mechanical systems needs early. And, it's what probably all architectural projects should do, building projects when we start out, but too often, and we've all seen it, um, you're designing away and nobody's really laid out the mechanical systems, and then they're getting shoehorned in. Uh, it's, hard enough for typical buildings. The big issue with passive house building is you have a much more extensive and space needy ventilation system because the ventilation is a core driver of the ultimate performance and the quality of the building. There's quite a bit of ductwork. This is all ventilation ductwork going down the hallway on the right, hallway ceiling. The hot water supply needs to be really well insulated and not just done as an afterthought. You need to be able to access it, and as well to the ventilation ductwork till that we know it's tight. And then we're appropriately sizing the cooling and heating systems. Um, so super important. Too many multifamily design teams ignore the space these systems require until after the floor plan is set, and it gets stuck and painful. So do everybody, what the volume, the populations and the areas, the volumes, the size. And we'll talk a little bit about strategies around that. So visualize the building from the inside out in schematic design. Looking at centralized versus localized, the other aspect, hot water tanks and heat pumps and how those are located. And looking primarily, although we talk about crushing the heating demand, we want to really zero in on the cooling strategy. The cooling system will deliver the heat, but the cooling, we want to make sure we've gotten that nailed down. Plant shading before glazing. This one maybe is not so obvious either. And we've got our nice friend, Unité de Habitation by Le Corbusier in Marseille, which will reappear a couple of times. It's not a passive house by any stretch of the imagination, but it has some great integrated shading as terms of the design, right? It's what, at least from the outside, what that building is really about architecturally. The big aspect of this, and exterior shading is something that's not big in the United States yet. There are some examples for sure, but something that we hope will be more and more prevalent, and the passive house should be a driver for it. We need exterior shading to avoid the unwanted solar heat gains. Um, we need to survive the heat waves. We need cooling as well, but the shading is super important. Multifamily buildings, because they're dense, there's so many people, there's electronics, people doing showers, people cooking. They're like little furnaces or big furnaces. Um, and so in the winter, they pretty much will heat themselves, even in fairly cold climates. Um, it's that overheating that is really the tough thing. We want to take a look at not necessarily wrapping the building in glass, or certainly not vision glass. We want to balance the needs of the occupants, and the quality of the space with the solar gains. So visualizing the building from the outside and seeing the shading first. We'll come back to this, still a little bit abstract perhaps. Um, Minimizing surface area. uh, any ins and outs of a building is going to um, create more surface area, create more cost. It's going to create more heat losses. And so it's going to mean more insulation to get to the same energy level. So a simple shape is the most efficient shape. Now, all our buildings may not be squares, or simple rectangles, certainly, but um, this is we need to be cognizant as we're making buildings more complicated, what the effect is. And certainly this is the role of using the PHPP and the energy model to see what these trade-offs are in real time as you're designing the building. Um, so, you know, we want to iron out the wrinkles, as we say here. Count the corners, cut as many as feasible, eliminate setbacks where possible, avoid structural cantilevers, and be strategic about the articulation of the building form. It's not, this is again trying to go to this most optimized. There are gradations of this, and depending on how forgiving your climate is, there are other possibilities. But in terms of cost effectiveness, energy efficient, high performance, as close as you can come to these, the better. Keep it simple. And that goes with form factor, although it's a little counterintuitive. A cube um, is a great form in a way, but in terms of form factor, because only one of the six surfaces is floor area, it's actually pretty bad in terms of uh, this top one, in terms of its form factor. So the form factor, the floor area ratio to the surface area, the form factor, and it's a really good indication of how efficient or optimized your building is, at least in the basic massing of it. If you go to a two-story building within that cube, um, it's from 6 to 1 to 3 to 1. So it's twice as good. And then to 3 stories to 2 to 1, and 6 story, it's 1 to 1. And so this is really good. Typically, we want to see a form factor of 2 to 1 or better. Like 2 to 1 is the kind of the threshold of being easier passive house and being optimized. If you're below, heading towards 3 to 1, not so great. Interestingly, I mean, if you keep adding floors and you build a tower, The form factor will increase, but it's almost get better. I mean, um, but it's diminishing returns. Really, the sweet spot is like that 6 to 10 story range um, in terms of form.
And
Um,
Ken,
yes.
there is a question in the chat.
Or convex corners over 90 degrees actually would seem to decrease perimeter cross section. Um, I suppose, I mean, if you're going one way, you got to go the other eventually somehow. I definitely, uh, if you're increasing the surface area with a curve, I mean, a concave, I don't, we'd have to look at the specifics of it. But to the extent that you're, I would just say, going from a simpler, more complex geometric form to a simpler one, you're going to have greater efficiency. Um, yeah, could dive into that separately. I think that makes sense. Um, I could see I could see both of those convex versus concave working out one way or another, depending on other contexts. So from form factor to the circulation area, um, we want to minimize the circulation. And perhaps this is an unfair comparison to The Shining. But double loaded corridors, nobody's a big fan of double loaded corridors, and yet we have them everywhere. And because they're seen as being very practical in many ways. And um, the thing about double loaded corridors are, and this isn't strictly passive house per se, except to say that typically we could do better in terms of circulation area as a percentage, getting away from a double loaded corridor. I'll explain that in a second. So it's about 13% circulation. The bigger issue is that you're really eliminating this opportunity for cross ventilation, um, and you're restricting the daylight into the space, and there's a certain uniformity that happens. And maybe that's more to do with development, the double loaded corridors, but they kind of reinforce each other. And this is where you kind of introduce, since you're doing a passive house anyway, start to think about some other ways of possibly approaching it. And so this is not perhaps so well known, but I think it's becoming more well known. This idea of a point access block. And what it is a block of units. So here you have 3 units around a single stair and an elevator. In jurisdictions, California, Oregon, Washington State, and others um, uh, have um, allowed single stair egress under certain conditions. And we see this much more widely used in Europe, but basically we can limit the amount of circulation, provide opportunities where the units have cross ventilation, um, different arrangements and sizes of units. And it's pretty exciting kind of thing. One of many things that Passive House kind of pairs with to make something even more special and high performance. The big proponent of this in North America at the moment is Michael Eliason, who's also a big Passive House proponent based in Seattle. And he's coming out with this book called Building for People, um, which is coming out, I think, December 12th. So we have no ties to it directly. I just know it's got a lot of amazing research and should be super interesting. And what we see again is the typical double loaded corridor, deep apartment, darker spaces, no cross ventilation, and then something where you have essentially a thinner building. Uh, you have the stair and elevator off to the right here, and a place where daylight can really come through the apartment. The ventilation can happen. It's more compact. Um, and you can see on the bottom, you have thinner buildings and more open space as opposed to our more typical American. This is Seattle, somewhere in Seattle. Um, double loaded corridor, fat buildings, no yards. It can spill over into many different combinations of uh, uh, of conversation. But we'll leave it there for the moment, um, and take a step back, perhaps, because we have had them in the past. Um, this is a single access stair building in New York City. Um, uh, Great form factor, surface area, and the circulation. So you've got these pins of stairs and elevator going to the different apartments. Um, so a lot of great qualities. It's also the building that only murders in the building takes place. So, fun fact. Kill bad balconies. Um, Balconies are really problematic for passive house because typically, they're cantilevered. And so how is that structural cantilever happening? How are you making it thermal bridge free? Now, there are ways of doing it, but it costs more money. It's more detail, and, a much bigger investment. Uh, Typically, our balconies aren't really big enough, or aren't really thought through. It's more like a real estate amenity, and people have balconies because people have had balconies. So you can't sell a building without having a balcony. Um, Maybe that's true. I don't know. But I think from a functional standpoint and from a performance standpoint, the idea here is that if you're going to have a balcony, great, but make it one that people are going to use and not just pile it with storage stuff and leave it for dead. Um, the kind of golden rule that we hear is that if it's less than 6 feet deep, people aren't likely to use it. Um, so our recommendation in terms of passive house is, lose it. Um, you can, of course, do it. On the right here, we have wonderful sort of balconies here that are freestanding off of the building, and another set of balconies here that are cantilevered. But they're doing it in a way that's very controlled and and able to deliver that passive house performance. Another key aspect here is to articulate the skin and not the thermal enclosure. So like we want that platonic box, right? The simplest geometry possible to have the most efficient form, fewest corners. But we see it all the time. You can wrap that simple thermal box in a great articulated, garment, if you will. And in this way, these are balconies uh, dressing up the building, grid around the building, all these different ways of doing it. And they're also providing shading, and they're usable, they're thermally broken. Here is more of a fabric. It's almost like a dress or pants on the building. Here, kind of like back to our unité, uh, where all of these balconies are not thermally broken from the conditioned space. Corbu is not doing that, but they could have been, and that's what this is, and that's what this building is too, right? And all of these, uh, you have the thermal boundary of a pretty relatively simple shape, and this whole architectural design over it is thermally separated from the enclosure. So you could have quite elaborate ins and outs, but the actual thermal enclosure is a simple box. And this is going to be the biggest thing in terms of saving money and making it effective in terms of being a passive house. You know, we see in zoning regulations, building codes may require a certain amount of articulation of a larger multifamily building. We see it all the time where they're broken down looking like smaller buildings of one sort or another. So you just want to think about it not as an articulation of the thermal enclosure, but of this fabric that's going around it, if that makes sense. Um, what's inside and what's outside. So this is kind of like, I guess, to be or not to be. Um, what can be outside of the thermal enclosure and perhaps should be. Certainly a parking garage. If you've got a parking garage, that's a no-brainer. Bicycle storage, vestibules, circulation elements. You see buildings where the hallways are included, but not often. Stairwells and elevators can be outside the thermal envelope. And it's a matter of the planning. And it could actually help, you know, inspire different design solutions. Storage lockers, the trash collection, commercial areas of mixed use buildings. So in multifamily buildings, oftentimes on the ground floor or the bottom two floors, you may have a different use entirely. It could be offices, it could be a nursery school, whatever. You may want to design it within the thermal envelope, but you don't necessarily need to. And certainly if it's speculative and you don't know who the tenant's going to be or what the use is going to be, you can take it outside of the thermal envelope of the passive house. So it's not like you have to do everything necessarily. You can make certain carve outs and identify that this is in, this is out. There are certain rules. We won't go into all the details there, but it's super important to be really clear about what's what. It's going to affect, uh, you know, not just the efficiency. Obviously, on the right here, uh, this carve out now is pulled this another step away from a cube, right? We've got another corner um, uh, added to this. Well, a number of corners based on the interior, based on the space. So um, but totally doable. Related to the ventilation requirements and, extensive when you've got a whole bunch of apartments on a floor and a whole bunch of floors, the ventilation really adds up. One way to help yourself when you're planning the multifamily building is to just make the ceilings a little bit higher. Now that may add some cost, a little bit of cost to the building, but in the simplification, in the execution, um, in the overall quality of the building, it can really make a big difference and really make things easier, make things accessible, um, and you may end up with slightly more spacious units. So it doesn't feel like you're in a similar shoebox um, uh, as, with the minimum ceiling height possible. Um, Again, accessing these pipes are going to get insulated and you need to be able to get to them, and they need to make sure that these ventilation ducts are sealed properly, and we need to be able to get to those. Um, so super important. Repeat what works. You know, architects, engineers, um, they have their systems, they have their details. They repeat what they can, and you want to build that library. And Passive House is no different. And there are lots of different libraries available, but you'll want to build your own. And some folks will just repeat entire buildings, not just the details, right? Certainly in window installation details, window systems, building modules, and the whole buildings. Here's a detail which will come back around, metal frame building. This is from a catalog from British Columbia Hydro. They have a wonderful catalog of construction details with thermal ridge analysis and all the different values in it, which is a great resource for doing bigger commercial buildings where it's not so readily available necessarily. All
And
right.
Ken,
Yes.
before we go into the next section, there's just a
Yeah.
couple of questions in the chat.
Oh,
Um,
sure.
yeah, the first of which is just a general question about cost per square foot of cylindrical or dome buildings versus rectangular buildings.
Yeah. Well, I, the short answer is I have no idea, but um, I have to believe that the more regular things are, the more cost effective it can be. So that argues for rectangular over circular. That said, that's what the bidding process of working with builders and figuring out the way that they can most cost effectively do something. I've been surprised on jobs where a builder will say, no, no, that doesn't cost anymore. That's fine. We can do that. And it really is a matter of finding the builders playing to their strengths is so much of the cost factor. So you know, it's not going to be cheap to wrap the Guggenheim, no matter which way you slice it. Uh, Certainly easier to wrap the rectangle they added to the Guggenheim than the original spiral Guggenheim. And then the 9-foot ceilings, floor plus parapet for 6 to 8 story buildings noted as optimum. Um, yeah, I don't know what an overall height would be. 9-foot ceilings, 10-foot floor to floor, so 60, 65 feet, 70 feet. I don't know, something in there. Really, I mean, there's so many different factors there, just the grade and everything else that could be there. But in that range, and it could be not a whole foot more, could be less than a foot. And floor build-ups, it could be different. So I hope that's not like a hard answer, but I hope that helps kind of like flesh out some of the issues. Good. Ventilation. The so state the obvious, cooking. There's a lot of ink on this now. Is the fossil fuel cooking is not healthy. We need to bring up the indoor air quality. The outdoor air qualities can be absolutely toxic, whether it's wildfire smoke or just the freeway that we're building multifamily homes next to everywhere. And so again, this is really just about driving the point home that ventilation is so critically important to multifamily being successful, multifamily passive house, that it's absolutely at the core of it. Um, and so you need to put a lot of thought in to make sure that it's cost effective and will operate. So again, going back to doing the layout, I need to find some more photos. Repeating, uh, you know, the big questions are local versus central. You could have um, every unit could have its own ventilation system, or it could be by floor, it could be by the whole building, which you see the diagram on the upper right. Um, there are lots of ways that could be coming down at the core and running down the hallway, like you see on the plan in the lower right. Um, you know, it needs to be integrated. It needs to be thoughtful, accessible, uh, and hopefully just as straightforward and minimized as possible. I think the bigger one, which I don't have a straight up diagram for, is the plumbing to really minimize the pipe lengths and to figure out layouts that are more efficient. So on the local versus centralized, this image in the middle is a unit ventilation system on its own in the high rise, in that dark black undulating building we saw a few slides ago. That's actually in Bilbao, Spain. Um, every unit has its own ventilation system. In this building, which is Cornell Tech, they looked at two ways of doing it, where every unit, every apartment had its own ventilation system in the ceiling. You see in the little section here, unit up, and then ducted, and you have all this mechanical system happening around the perimeter to get back to the kitchen and whatnot. And then what they ended up doing, putting a big central heat exchange ventilation unit up on the roof and having risers go down through the building. I will just go out on a limb and say, a key thing is that, oh, this is the next one. Strategies between um, the pros and cons of local versus central. Um, I would say it comes down to that the filters need to be changed regularly. And if the filters aren't changed, you're not going to get ventilation air. They're going to clog up because there's just so much damn pollution out there. And to me, it really argues for going for centralized system, that you have them professionally maintained. You don't have to access people's units. Um, and uh, and and it's part of the functioning of the building, basic building infrastructure. If you have individual units, it's just more stuff for the occupants to play with and mess with. And you've got to get into the units and change the filters and all of this. Not to say you can't do it. Many, many buildings have done it unit by unit. I just say really exhaust the central central option first. We see it really common now, and yeah, just very well done. Related to ventilation directly is the kitchen ventilation and the laundry ventilation. So ventilation requirements can seem to vary quite a bit. Um, but at the end of the day, what we see with passive house is essentially a hybrid approach where you're using a recirculating range hood over presumably an induction cooktop. So we have much less pollution. We're just knocking down the grease with the range hood. And then you have the central or decentralized exhaust outlet near the stove in the kitchen, but not right over it, pulling air out of the space and filtering it again through the main system and providing fresh air. So a hybrid system for that. The range hood's operating intermittently, while the ventilation system of the passive house is running continuously. The clothes dryers, typically vented clothes dryers, exhausted clothes dryers, they're use massive amount of CFM, and you can figure out a way to get around it in a single family house. But in a multifamily, it's just would be an insane amount of energy loss and quite impossible. So we don't want to, if we're having clothes dryers in the units, we want them to be condensing or heat pump dryers without exhausts, right? So it's just staying right there. You can have laundry rooms, and the laundry rooms can be another one of these items that's pulled out of the thermal envelope, or it could be just separated within the thermal envelope, where you have airtight separation from the other spaces. You have local makeup air and a fan coil needed. So you're relatively inefficient, but you're in this one laundry room. And you can make it work if you've got enough units, if the building's big enough. Um, the final note on ventilation is sealing the ducts, quote unquote, perfectly. There's a lot of talk about sealing the building envelope and having building blower door test and making sure we get that. It's absolutely critical. Um, talk about that. But what's less talked about is the need for the ventilation ductwork to also be airtight. And many duct contractors will say, oh, we do, perfect. We can hold a column of water with our ductwork. It won't leak. No problem. But it's really not the case, unfortunately. Typical ductwork standards in the industry, they could see 30% duct leakage. We want for passive house, it's recommended to be under 3 or 2% duct leakage of the airflow. Um, so we're looking at the specification, we're looking at making sure that they're on board. And then ultimately, if the project allows on day one to backstop that with aerosol um, uh, air sealing. So AeroSeal, I'm waiting for somebody to tell me that there's another product out there that can do this. But until I hear is the AeroSeal duct sealing. And so you see on the right in the picture, they are um, sealing and testing the duct. Um, and you'll know at the end of the day that you actually have ducts that are tight enough that you can balance and commission the system at the end of the day and hit the numbers that you need to do to be certified and deliver the results. If you don't have a plan in terms of delivering very well sealed ducts, if not perfectly, it can be a real disaster for projects. Um, and very hard to then get it. They'll get there, but the pain and suffering is just too great. There are lots of ways to avoid it. Exterior shading, sensible glazing. Again, the world's getting hotter. So, it's going over 100 degrees everywhere. And in such conditions, we need to have cooling, mechanical cooling, of course, but we need to help that out. We can't just tackle it with cooling. We want to minimize the overheating. And the density and everything that was spoken about is just really pushing against it. Um, So why do we push for mounting shading on the outside of the building? Because it's much more effective, right? If we kick it down, shading inside the building, most of that energy is still getting in. This is a little image of Wolfgang Feist, founder of the Institute. And if we have external shading, the vast majority of it's staying outside. Huge difference, interior versus exterior. So if we could just get with the program in terms of architecturally dealing with shading, um, uh, it's not an issue. And we see on the right just the diagram of different shading types. And depending on the orientation of the facade, you'd want to do something different. Vertical on the western facade, not as deep on the southern facade, deeper perhaps on the eastern and so forth. So you want to nail all those down. Um, let's see here. Oh, there's a question here on the AeroSeal. So is it necessary for the ERV, HRV duct work as well? So, well, just to separate, so we're talking about just the ventilation ductwork, not the heating and cooling ductwork. So it is the ERV, HRV ductwork. To make a distinction though, you may be thinking of the flexible like plastic piping that's often used with the decentralized systems or where a centralized system is broken down in its distribution. It looks like spaghetti going in 1,000 directions. Um, the uh, that spaghetti like plastic stuff is pretty plug and play, and you're not aerosealing that at all. You'd just be looking for typical leakage issues. But where you have metal ductwork on the big central ventilation, ERV or HRV, that's what we're looking to aeroseal. Great. And then let's see here. There was another one, I think. AeroSeal. I tried to specify for a retrofit project, partially due to the contractor missing it in the drawings due to public work procurement. We didn't get it. Yeah. Um, it's one of those things. So it's one of those items, and there are many. I think we'll come back around to this. Is like, you know, double check, triple check in terms of making sure what's in the bid and what are the critical things. So now understanding that the ventilation is just so incredibly important to make that happen. Yeah, in terms of the procurement is another issue. And that's why I'd love to see competitors for AeroSeal and make sure that we can have options and be able to provide that. Great. Let's see here. So visualize shading before anything else. Lots of different shading aspects out there. And I added to Corbusier on the lower left, we've got Louis Kahn now. Um, and great architect with light and shade. Um, so lots of different things, lots to learn from traditionally hot climates from the Middle East, right? How are they dealing with these, with the brise-soleils, exterior shutters, the balconies, rolling shutters, canopies, all these different ways of doing it. Uh, Super important. Such a broad range. It's a real palette architecturally and in terms of the user interface. I like to say if your design team can't see exterior shading that works for your building, get a new team. So we like to be a little drastic here. But that's not to say things can't be worked out in a number of ways. And we see shades between the panes of glass too. It's just relying on inside shade and then relying on owners, occupants operating the shading is a disaster. You know, they're just not, nobody's has those habits. You may see, in more in higher end applications, external shading that's um, on a system that's on a motorized system that's programmed to move with the sun and the different conditions. That sort of operable shading would be great. But you can see architecturally, there's lots of variety. Key aspect we like to hammer home in our passive house education, I think it's worth repeating, is that window frames are the weak link. We don't like window frames. We do like glass. Window frames should be minimized and the glass maximized. That said, we want to balance, right? So we don't want multiple panes of glass with these mullions if possible. Much better to have two windows than have four windows. You see by the U values, just going from the smaller window where a greater proportion of that window is framed to the larger window is much better performing than the smaller window thermally. It's going to be much better for your building. So doing fewer, bigger windows is more affordable both thermally and in terms of cost than doing more smaller windows. Um, and right, it's about striking that balance. But from a focus point of view, you want to be eliminating window frames as much as possible and having as great a proportion of glass to frame as possible. And, have that quality again, right? We want the windows to have purpose, whether, it's common area, the wall of windows, the staircase. Here, this woman is sitting, you see this in passive houses a lot where you have a deeper wall typically, and because you don't have a heater right there, and you have this depth to the window can become a window seat. The glass doesn't need to go to the floor. It's not providing you any more daylight deep into the thing. You can actually use that space and have pretty straightforward and effective methods. So that's windows. Thick walls, and I put it in quotation marks particularly because we're dealing with California and Southern California. Um, and I have a fun example here. So walls, going back to an earlier comment, they can be of really any type of construction, could be made into a passive house. It could be wood frame. You know, if we're talking 6, 7, 8 story, 4, 3 to 8, whatever. You know, we can do all sorts of construction types. And the typical thing is to, you know, stuff it like we have this double stud wall here where we're filling it up, or it could be exterior. So here we have the studs. Oh, I'm sorry, I'm pointing at the wrong screen. The double stud here where we're stuffing it, um, or all exterior where the studs now don't have any insulation. It's a service cavity and all the insulation is outboard, similar with the mass timber. Or it could be a hybrid where we've got some in the framing, some outboard. This could be with concrete um, construction, also with metal frame construction being used all the time. The key thing with a lot of multifamily building today is that we want to make sure that that rain screen facade is thermally broken in how it is attached to the building. So there are these Cascadia clips that are intermittent, made of fiberglass. Um, and there are other competitors out there that are drastically reducing the thermal ridging. The traditional kind of Z grit uh, clips, Z-girt clips were just huge, massive thermal bridges undermining all the insulation behind it. And this we can maintain the performance. So again, going with what you're comfortable with, the market's comfortable with in terms of building, what the builder's comfortable with in terms of building, it's doable. And so here's our fun little experiment. This came from our conference last year in Denver, where we said, hey, this is part of a big complex in East Harlem, New York City. 3 buildings, uh, or 2, I guess, a high rise with a low rise attached to it, building A, or no, the high rise is A, the north higher building is B, and then the south building. So this is a relatively modest size building. You can see the ground floors are different use. So it's really, they're looking at the residential floors for the certification with the building lobby for the residential portion is part of it. The values in New York, you know, it's a 6-inch ephes assembly with um, uh, with a service cavity that has insulation as well to get to the R value uh, as that they need for it. If we move to Denver, it goes thicker. Or did they not insulate the stud wall? Maybe they didn't insulate the stud wall. And in Denver, it has to go thicker for the exterior EIFS system, and they insulated the stud wall. Sorry about that. But we moved the building to San Francisco, and there's a steel stud wall as a service cavity. There's no insulation in that. And there's 3 inches of EIFS on the outside for the Bay Area, which is just, you know, and this is the optimization of dealing with thermal bridge free construction, air tightness, volumetric optimization. You know, it's a pretty regular, it's not a perfect rectangle or anything, but they've done a lot to optimize it. And so we're talking about a shockingly low level of insulation. It's R14 to hit passive house performance. Um, so I think, you know, that could be liberating and is the reason for pushing for all the other optimizations. And it's really a balance. So panelized system is also something that's coming online in a whole bunch of different ways. Different building types, multifamily, high rises using mass timber here, but also just innovative kind of eye candy, which is happening and is coming to the United States, is straw filled panels. So it's wood timber framing packed with straw, prefabricated, and doing multi-story, multi-family buildings now with it. So that's exciting. Needs to be affordable, really needs to be done locally. Um, so let's look from, so not so thick walls necessarily, to thermal bridge pre-construction, thermal bridges and multifamily. And in any building, thermal bridging can really undermine the performance of the building. It's like dying by 1,000 cuts. All the penetrations, it can account for 20 to 30% of the heat loss in a multifamily building. And this is one of the reasons why mechanical engineers will want to oversize systems, quote unquote, oversize them, because in typical construction, they don't believe that the building's actually going to perform the way it's calculated to perform. They want a big um, uh, 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 big allowance there for error. In a passive house, we're taking all those possible leakages and identifying them, calculating them, getting them into the energy model. And so you're dialing it down while we're still providing some allowance going into construction. Hopefully, we're not right on the line, but perhaps we could be going into construction. What the mechanical engineer has uh, um, going is that they've got a very specific number to go for. They don't need to oversize it the way that they are used to doing. So we're assessing all of these thermal bridges. It's really important to identify them early and to put in placeholder values early. So a thermal bridge, just again, they could be linear thermal bridges. They could be point thermal bridges. So a linear, linear thermal bridge is like the joint between the floor and the wall. Here you have a weakness. Sorry, putting it the wrong screen. The joint between the floor and the wall. And at this corner, we have a weak point where we could have a thermal bridge and it could be pretty bad. We want to minimize it, eliminate it, but whatever's left, we want to calculate it, what the condition is. Could have point thermal bridges where structures coming through, um, those clips holding up the rain screen facade, things like that. And the windows are probably the biggest issue and goes back to the importance of the windows again. How the windows are detailed, how they're installed, how the insulation wraps around the frame or doesn't. Oftentimes we can get the jambs in the head pretty good if they're optimized and can be really robust. The sill is a much harder thing to tackle, and they're typically worse values, certainly, almost all the time. Uh, I think, just getting those for a building, for a multifamily building, so critical to identify all these thermal bridges and get them into the model early. All right. Oh, and I should put this on this image is a set of details that come with a certified window certificate. So at the Passive House Institute, there are many, many, many certified windows. Um, what they're really certifying is the frame performance. Again, the glass can be, they're using like a standard glass value. They're certifying the frame performance, and then they're certifying in the install value based on certain conditions. To the extent that you have a custom condition, which most of the time is the truth, the reality, you're going to do the detail and have somebody calculate, or you're going to calculate the thermal bridging value for these windows. But for this certified window with the certified frame, they've got thermal bridge values for the install for the head jamb and sill that come with it. So it's a great place to get those placeholder values if you think the construction is going to get there. And you have a building with 1,000 windows and miles of perimeter, right, of window. And every perimeter of every window is a thermal bridge, and a bad one potentially. So nailing those down, super important. Cooling, heating, and hot water. So pretty much everything that we've talked about up to this point is like core to those 5 passive house principles. Now we're kind of stepping out. Now it's like, okay, what's the resulting cooling and heating needs for the space? And then we'll look at hot water. So once again, I guess we can't overemphasize it. It's obvious enough. It's about survival as much as anything now. We want to be comfortable, but we don't want to have to flee. We want to be able to be in our homes, in our schools, whatever it may be, and certainly multifamily buildings. So, this is not a surprise. We're talking about heat pumps, and typically we're talking about air source heat pumps. Um, it could be ground source, and I don't have it in here, but there are systems in bigger multifamily buildings. They're doing hybrid systems where the air source heat pump with ground source and optimizing. So they're not totally dependent on the ground source uh, for their cooling, and it seems to be working well. So this system is going to provide the cooling and the heating. So you're putting in one mechanical system for the thermal comfort. The big aspect, I guess, as a passive house practitioner, and it's not necessarily a certification thing or at all, but we want to limit the air conditioning greenhouse gases that are escaping. There's huge leakage associated with air conditioning systems. And so the more refrigerant piping we have running around the building, the more chance we have for leakage. And when refrigerant pipes leak, the problem can go undetected for a long time. And you need specific technician, and the system needs to be recharged, fixed and recharged. Um, so uh, what we're seeing is, packaged units, um, or looking for ways of distributing the air conditioning, the cooling and heating in um, less damaging, specified low uh, global warming potential refrigerants like R32 or better. We see propane being used, which sound worrisome to some people, but it's quite. I think it's a one. It's a has a global warming potential of 1, same as CO2. And what we're looking to do is, rather than um, distribute out to the units with refrigerant through the building in a variable refrigerant volume system, um, flow system, using hydronics. Now, it's not required, but what we're seeing and what we're looking to kind of normalize is using a hydronic, using water uh, for distributing the cooling and heating to the uh, the air handlers for the actual space conditioning. So you're going to have an air handler in the unit. Um, some are going to want to be warmer than others. Some are going to need cooling, while another needs warming. But to do that with water and minimize that.
And Ken,
Yeah,
I don't mean to rush you, but I just want to let you know that we have a little less than 20 minutes left.
yep, yep, yep. I've got my eye on it. I think we're okay. I'm going
Perfect.
to try to wrap this up post haste. Yeah. Thank you. Uh, so multifamily heating, cooling, and dehumidification. So, so an interesting development that's coming online now in terms of in terms of decentralized system is this through wall in many places, and I know in New York there are through wall package units which are called PTACs and are terribly loud and inefficient and horrible things. But there are new systems coming on board that actually provide heating and cooling, and ventilation is possible with the unit going through. And they're as airtight as need to be for passive house and can have the thermal performance required for passive house, which is super exciting. So we're looking for options with that. But typical systems like that. Dehumidification. Nice thing about a central system is you can add dehumidification to it. Probably not needed in your area, but for much of the country, super important. Domestic hot water. Um, Centralized system, again, we see more and more of. So air source heat pump. This is traditional pipe system on the left, where it's going down and then up to each. And this was actually a design process for a building. And then they went and simplified the piping system. If you can reduce the amount of piping, it's like reducing the size of the radiator in your building. So all that piping is throwing heat. Now we're going to insulate them well, but it's still heating the building. And so the more pipe you have, the more heat you're losing, and you have to make it up with cooling um, for the space, if that makes sense, because you're heating the space. So we want to find strategies to minimize the pipe lengths. Now, one thing folks may do is to unitize the hot water heater with a heat pump, which is entirely possible. There's issue with noise where the compressor is right there, condenser, and we want to duct um, the uh, the cold air that it's throwing off when it's heating the water to another space. We don't want to need to heat the space because we're making hot water, which is throwing cold air into the apartment. One way is to possibly have the access from the corridor and do it that way. So we see buildings, large multifamily buildings, doing either of these approaches. And I think it has more to do with the culture of the area, whether it's centralized or unitized. But I would definitely argue, for what it's worth, to move towards a central system that can be well maintained and operated. Electrification, back around. So we have this idea of all our energy is coming from renewable energy. The grid is green. The direct use is the most efficient use of that energy to any sense that we need storage, whether short term or seasonally and long term, we're going to have greater losses. And depending on what the use is, that profile is going to be different. It all ties into what we call primary energy renewable. And the one note here is that the primary energy renewable limits adjust per occupancy type. And so a multifamily has higher energy use, density use limits than single family would, let's say. A couple more things in terms of the electrification on this is, so it's how it's measured is by different use categories. So the heating is typically going to be the worst offender in terms of being asynchronous. It's not when you have the most renewables. It's going to be in the season, and long-term storage is going to be required. So it's often going to have a worse PER factor. Cooling is better. Dehumidification depends. Hot water is constant. Other electric uses can be constant. And depending on where you are, what the profile is, if your region has more sun, if it has a certain baseline of hydro, if it's windy or not windy, you have a theoretical projection of what that renewable capability is. And so you're tuning the building again to this future renewable all electric world. Storage. The other thing we want to do in terms of electrification is, use as little as possible, obviously, in with elevators, picking the most efficient elevator, but also doing great stairs so people don't necessarily want to use the elevator, that they can use the stairs and go up and down a few flights of stairs. Um, and providing the daylighting and bringing those combination of things together. This is a multi-family building. Appliances, monitoring, and metering. A few things to state the obvious. We want as efficient appliances as possible. Energy Star is the baseline. The better rating, of course, the better. Energy monitoring is not required in Passive House. It's based on the final PHPP and the as-built conditions. But oftentimes people will want to do it and encourage people and help people's behavior that way. Metering, yeah, is problematic in terms of whether it's a unit or the whole building. Depends again, basically on the approach. The loads can be so low that the service charge is basically what people are paying, and hard to get reductions, the full reductions that you would be looking for there. The other thing I would just say on monitoring is, ironically, the word is that a lot of the monitoring systems can be quite energy inefficient, and they use a tremendous amount of energy to monitor the efficiency of the building. So you want to make sure that you are choosing an efficient monitoring system um, for that. And then renewables. On-site renewable power is not required for Passive House certification. Is certainly encouraged. How Passive House looks at it is not what you've got on site. It's how well you're using the building footprint on that land, and optimizing it. So it doesn't want to incentivize two-story buildings, which are kind of optimal for, net zeroing out and having everything covered by renewable on your building. They want to be able to do a 20-story building and reward effective integration and deployment of renewables. All right. Building certification. A pitch for building certification for multifamily building in all buildings is that the architect and design team receive third-party assurance prior to construction that the plans will achieve the standard, that design assurance that we talked about. The construction team receives verification of build quality and performance. Really great for the contractors to know that they've delivered this great result, and in terms of what they can do as builders, we've seen it be really transformative. And typical builders going through a Passive House project or two emerge being able to just knock it out of the park. Funders receive proof that they got what they paid for, and residents receive a home that's quieter, more comfortable, healthy, and more resilient than all the others. So, really something of high quality and value for a whole bunch of reasons. I won't spend too much time with this. The criteria for buildings, really uh, out explicitly states what's required. And then in terms of the verification, the different items that are required for it. Building's complicated, but the focus of Passive House is very specific. There are over 30 certifiers, building certifiers working in the United States. You can find them on our website. You can find them on the Passive House Institute's website. There are a range of service types. We have this guide, which you can download, Building Certifier Scope of Services, from pre-design, preliminary review, through certification. A variety of things that the certifiers may or may not provide. You could, if you know what you're doing, you could build the building, not ever talk to a certifier or hire a certifier, then have all the information, call up the certifier, hand it off, and get it certified. But you have to really know what you're doing. Most of the time, you're going to be using the certifier to help you with their institutional knowledge so that you're not making mistakes that people have before you. Just a quick note, as on this, the consultant, Passive House consultant is team facing, is part of the team and facing the certifier. Passive House consultant is the vehicle for going to the certifier, and the certifier is receiving all that information and going back and forth with the consultant and team, and interfacing with the institute. The big thing just to say on hiring one is to hire one early. Don't wait when you're new to Passive House. On day one is not too early. Verification plan goes back to the things that we've really focused on: the air tightness system, the ventilation, and we haven't really talked about it, but unvetted component substitutions. That things may seem innocuous, but you may not know what to look for. The supplier, the manufacturer may not know what's what. And something that seemed innocuous can prevent building certification because it wasn't vetted through the PHPP and the certifier. The platform, as you're working through the process, all the different team members are funneling the information again through the consultant. Everybody can watch on the platform what's done, what's open, what needs to be taken care of, but it's just the certifier and the consultant on the platform. So in conclusion, go back to that opening charrette, putting everything on the table. I'd say construction kickoff and training mock-ups, getting the workers, the builders connected to those performance drivers is so helpful. Retaining the certifier early, that Passive House focus for the pathway, and just make sure that all these different aspects you're taking into account. Yeah, and it's just kind of building on that. Higher experience, the team itself, or get coaching, get input from folks as you need it along the way. And becoming a certified Passive House designer or consultant is critical to being able to internalize this and having a foundation. It's really the starting point. I like to consider it as graduating from college, where you're not really ready to be an architect, professional architect graduating from college, but after some projects and working with the team, you can do it. The verification course is very helpful. So some resources. Again, I'll share this link as soon as I stop talking, and you can link to all of this. This is more what was through the presentation and more. Thank you. That's it. I'm sorry I'm so close to time. I'm totally happy to take questions and stuff going forward. Sarah?
Yeah, thanks, Ken. Yeah, I'll just run through my closing slides really quick, just so we can get those kind of out of the way, and then we can open it up for questions. Just a reminder that 3C Ren offers our free energy code coach service. It's for questions related to Title 24, Part 6 or Part 11, the energy code or Cal Green. So we always just try to plug that as a reminder to folks that have any questions. Feel free to reach out to us. And then if you can go to the next slide. Yeah, thank you. There are AIA learning units available. So if you need to send me your AIA number, my email is there on the screen. But if you provided it during registration, I have that and will confirm your attendance, and then pass those over to Passive House Network to report your attendance. And then we have our upcoming courses listed there. I also just wanted to launch a poll. It's a Zoom poll. It just helps us gauge how the course was delivered today. It just gives us a little bit more information. So we appreciate any type of feedback. And also you'll be getting the slides and a link to the recording, and also a different survey in your email in the next few days. But with that, if there are any questions, please feel free to unmute yourself or ask them in the chat. We have a few minutes.
Yeah, happy to. discuss any aspect. And let me get that, that link here. There's the link to the deck.
Great. Thanks, Ken.
Yeah, absolutely. So anybody has questions, if not now, in the future, something comes up, feel free to send me an email, or I can either hopefully answer or point you in the right direction. My email is or oh, there's a typo in that. Yeah,
Great. Yeah, well, yeah, thank you. Yeah, if there's no questions, I'll go ahead and close out the course today. But thank you all again, and thank you, Ken, for a great course. Lots of information.
too much information, maybe. I need to weed it out. Thank you. It was a pleasure.
Yeah.
And hope to connect with everybody again sometime.
All right. Thanks all. Have a good rest of your day.
Thank you. Bye-bye.